Okay, we are going to learn about solution chemistry. Okay, we're going to talk about different types of solutions, what that means. We're going to bring back some words that we have learned previously in this year, and then we're going to do some calculations at the end. So, the first thing I want to talk about is what a solution is. So, in chemistry, a solution is a homogeneous mixture of two or more substances. Okay, so homogeneous mixture is something we've learned about before, where we have a mixture of two things. Now, one of the substances is going to be dissolved, and this is called the solute. Okay, the solute can either be a gas, a liquid, or a solid. So all of those substances can be dissolved. And then the substance that is in which the solute is being dissolved is called the solvent. And the solvent can either be a liquid or a solid. Okay. Usually we're going to be dealing with a liquid. So you dissolve something in a liquid, for example, water, but you always dissolve the solute into the solvent. So, one example is a can of soda like Coke, which lists its ingredients as carbonated water, high fructose corn syrup, and or sucrose, caramel color, phosphoric acid, natural flavors, caffeine. What is the solvent, and what are the solutes? So, if you think about a can of soda, okay, what is being dissolved, and what are you dissolving it in? Well, in this case, okay, after you've thought about it, the solvent is what is being dissolved in, and that would be the water. Okay, everything is being dissolved in water. So that means the solutes is everything else. Okay, the carbonation comes from the gas, the dissolved carbon dioxide, the corn syrup, the caramel color, phosphoric acid, all that gets dissolved. So those are solutes into the solvent, which is the water. Now, there are different types of solutions that you're going to be coming across. One example is a gaseous solution. So, the air is a mixture of different types of gases like carbon dioxide, oxygen, helium, nitrogen. Those are all dissolved in each other. A liquid solution is probably the one you're most common with, and those are your drinks like the soda on the previous slide, or an example like lemonade or Kool-Aid. But you can also have a solid solution. Two metals can be mixed together into a solution. And an example of that would be steel and bronze. Two other words that you might have come across or be familiar with are miscible and immiscible. So, a miscible liquid is something that easily dissolves in one another. Okay, so if you have two liquids and you mix them together, they will easily dissolve in each other. An immiscible liquid are not soluble in each other. Okay, they do not dissolve. Okay, so we have two examples. The one on the right would be a miscible, where it's mixed together. You can see the different particles all combined in one test tube here. The picture on the left, or the test tube, shows two very distinct layers, and you can see that in the particle diagram, okay, where you see the atoms and the particles. Okay, those are immiscible. Okay, a classic example is with cooking. When you have oil and water, those do not mix with each other, they do not dissolve. Those are said to be immiscible. So, one of the key words you're going to hear about in this topic is solubility. So, the definition, or how we define solubility, is the maximum grams of solute that will dissolve in 100 grams of solvent at a given temperature. So, solubility does vary with temperature, and it's based on a saturated solution. Okay, so solubility, the ability to dissolve something, but it is dependent upon temperature, and different solutions, as we'll see, different solutes can be dissolved based on what it is being dissolved in. Here we have a classic example of salt and water. Okay, moving on with solubility, there are different types of solutions based on the amount of solute that has been or can be dissolved. So you can have what is known as an unsaturated solution. That means more solute is able to be dissolved. You can continue to add those salt crystals, for example, or sugar. A saturated solution gets to the point where no more solute is able to dissolve. Okay, you've reached the maximum amount. Okay, where you might have some of those salt or sugar molecules at the bottom of your test tube, as you can see in the second picture, or in a cup of coffee. Eventually, if you add so much solute, some solutions can create a supersaturated solution where the solution becomes unstable and you get these crystals forming at the bottom. Okay, so make sure you understand the difference between an unsaturated and a saturated solution. Now, I mentioned before that solubility does depend on temperature, and we can use what is known as a solubility curve to show the dependence of solubility on temperature. Okay, this is something you're probably going to see down the road as we continue this unit, but you can see that there are different types of gases and solids, and the curve shows the amount of solute that can be dissolved at a particular temperature. So, for example, if you look at KNO3 in the middle, you could see that as the temperature increases, you can dissolve more and more of your solid. Okay, most of the time you can actually see that is the case. When you increase the temperature, you increase the amount of solute that you can dissolve. Okay, so become familiar with this graph. Like I said, you're probably going to see it again moving forward. Now, here are two terms you have definitely heard of before. That would be something that is dilute versus something that is concentrated. So, if you have a solution that is dilute, it is a solution that contains a small proportion of solute relative to the solvent. Okay, you have a small or a tiny amount of solute. On the other hand, a solution that is concentrated, well, it contains a large proportion of solute relative to the solvent. Okay, it's like if you put a little bit of salt into a cup of water versus, a lot of salt. That would be the difference between dilute and concentrated. So we could take a look at a picture in terms of the amount of particles. Okay, so on the left-hand picture, we see a concentrated solution. There's lots of solute, but little solvent. Okay, if the blue particles represent solutes, we can see there is a good amount of them relative to the purple particles, which are your solvent. That is a concentrated solution. You can see that in the picture there of our liquid or our solution there. It is quite dark. There's a lot of solute particles. Okay? On the right-hand side, though, our dilute solution, in our beaker, we have lots of solvent but little solute. So we could have, let's say, lots of water as our solvent. And those are the purple particles, which we can see there's a lot of them. And only a tiny amount of the solute. We can see that in this beaker, it is a lighter color because there aren't as many solutes. So dilute and concentrated are certain ways to talk about how the concentration of that solution is. There are four main ways that we're going to talk about concentration. There's something called percent composition, molarity, molality, and mole fraction. For us, the one we're going to look at is molarity. Okay, so molarity has the word mole in it. That's going to play a very important role as we talk about concentrations. So molarity is given by the symbol capital M. Okay, it's a way to represent the concentration of a solution. So there are two pieces of information that you need. The moles of the solute present in the solution and the volume of the solution, and it has to be in liters containing the solute. Okay, so you have to know the moles and the volume has to be in liters. Okay, so a simple equation is to calculate the molarity. You take the moles of the solute divided by the volume of the solution in liters. Okay, now the easiest way to remember this equation is to actually use a triangle. Okay, we've used a triangle before when we talked about density. We had our density triangle. Well, this is our molarity triangle. Okay, you see molarity, and on the left you have moles on the top and you have volume on the right hand side. So from this triangle you can get three separate equations based on what you are looking for. So if you were trying to define the molarity, trying to find it in a problem, you would take the moles divided by the volume. If you're trying to find the volume, you would take the moles and divide it by the molarity. And finally, if you're trying to find the moles, you would take molarity and multiply it by volume. Okay, so if you remember how to do the triangle, you cover up the variable that you are looking for, and if the two resulting variables are on top of each other, you divide, and if they're next to each other, then you multiply. Okay, so you should definitely remember this triangle. Okay, it will be given to you, so you do not have to memorize all three equations that you're going to use. So let's do a couple of examples that you're going to see. You're going to be practicing this next week. Okay, so a simple problem might be find the molarity of a solution containing 2.5 moles of solute in 10 liters of solution. Okay, so think about what you're given, what you know, and what you have to find. So we're given the amount of moles, and we're given the volume, and the volume is in liters. We need to find the molarity. So from the triangle, we know that molarity equals moles divided by the volume. We plug in the 2.5 moles, and then we can divide it by the 10 liters. And when we put that in our calculator, we get the molarity as 0.25 m. Okay, 0.25 molar. Okay, remember that capital M is our unit, our symbol for molarity, our concentration, 0.25 molar. Okay, always with problems like this, identify what you know and identify what you're trying to find. Let's look at molarity example number 2. Find the number of moles in a 0.5 molar solution made from 0.100 liters of water. Okay, so again, we have to figure out what are we given. Well, we know the concentration, we know the molarity, 0.5. We know the volume, 0.100 liters of water, and we're trying to find the moles. So go back to the triangle, look for how we can determine the number of moles, and you'll see that the equation that we need is moles equals molarity times the volume. We know the molarity and the volume, so we can input those values. So we're going to do in our calculator 0.5 times 0.100 And when we do that, we calculate the number of moles in our solution as 0.05 moles. Okay, so go ahead and write that down in your notes. Okay, here is a third example. Here we're going to find the molarity of a solution containing 76 grams of KBr, potassium bromide, in 0.2 liters of water. So we have to find the molarity, we have to find the concentration. So we know that molarity equals moles divided by volume. That is from our triangle, that is the equation that we need. However, we are not given the moles in this problem. We are, however, given the number of grams of potassium bromide, of KBr. So the first step that we need to do is to use our mole map, and we have to find the molar mass of KBr and convert grams into moles. So usually when you are in a lab doing this kind of stuff, you're not going to be given the moles, but you can always find the grams. You can measure that out. So we do 76 grams times our conversion of 1 mole divided by the molar mass, 119 grams. So 76 grams is equal to 0.64 moles. So once we know that the molarity equals the moles divided by the volume. We plug in 0.64 moles divided by our volume, 0.2 liters. Put that in your calculator and you get the molarity as 3.2 molar. Okay, so a problem like this, if you're not given the moles, but you are given the mass, you're given the grams, you're going to have to first convert it to moles, which you know how to do using your mole map, and then you divide it by the volume. And let's do one more example, number 4. Find the number of grams of NaCl, sodium chloride, that are required to be added to 0.5 liters of water to make a 0.3 molar solution. Okay? Let's say you're in the lab and you're asked to make this concentration, this specific concentration, and you have 0.5 liters of water. How many grams of salt do you need? Okay, you actually have to calculate this. Okay, well, we need to find the number of grams, but grams, the mass, is not in our triangle. But we can get the grams from the moles. So our first step is to calculate the moles, because what we are given is the volume and the molarity. So we can find the moles by multiplying those two values together. So we take the molarity, which is 0.3, multiply it by the 0.5 liters, and we get 0.15 moles of sodium chloride. Well, in order to convert it to grams, we look at our mole map. We have to multiply it by the molar mass. Well, the molar mass of NaCl is 58.44 grams. And when we do that, we know we need 8.77 grams of sodium chloride, of our salt. Okay, so if we took a balance, added 8.77 grams of salt, added it to a beaker containing 0.5 liters of water, we would have a 0.3 molar solution. Okay, make sure all of your examples are written down. You're going to be practicing with this next week.